Hello, and greetings from ICMR National Institute of Epidemiology. Causal inference from observational studies, abbreviated as COSET, is one of the e-certificate courses offered by ICMR National Institute of Epidemiology. I am Hemant, and I will be taking you through an overview of threats to validity. Now, this topic is divided into two sessions. First, internal and external validity, and the second session on threats to internal validity. Each session will be around 10 to 15 minutes. Let us go through the first session, internal and external validity. And then, in a separate session, we will go through the threats to internal validity. Before we begin, let us go through some terminologies. This refers to target and source population and study sample. Target population refers to the population to which we extrapolate the results from a study. Study population is the population from which the study subjects are drawn. Study sample includes individuals that end up in a study. Study population is also a phrase that is commonly used, and some authors use it to denote source population and some use it to denote study sample. In epidemiologic studies, we all deal with samples. We want to measure something in our target population. Let us call it population parameter, the truth. In the source population or study sample, we get something called as the sample estimate. Then, from the sample estimate, we generalize it to the target population. This is what we do in epidemiologic studies, unless the target population is completely included in the study. For example, census. The first objective in any epidemiologic study is to obtain an accurate sample estimate from the source population or study sample that is valid and precise. This estimate could be frequency or mean in a descriptive study or the effect of an exposure on the occurrence of a disease in an analytic study. The second objective is to obtain a sample estimate that is generalizable to relevant target population. After this, let us try and understand the terms validity and precision using these four dartboards. Let us assume that a study was conducted in multiple hypothetical random samples more than once using the same methodology within the same target population. Now, the center of the dartboard would be the population parameter, the truth, while each dot represents the sample estimate. The dartboard on top left is an example for a study that is valid as well as precise. That is, the dots are closer to the center of the board, indicating valid estimates, and the dots are clustered close to one another, indicating precise estimates. The dartboard on top right is an example for study that is precise but not valid, as the dots are together but away from the center. The dartboard on bottom left is an example of a study that is valid but not precise. And finally, the one at bottom right indicates a study that is neither valid nor precise. With this understanding of some commonly used terms, let us understand the errors in an epidemiologic study. The errors are classified as random and systematic error. Random error is also called as the sampling error, the error that happens during random sampling. Random error reflects the variability in the sample estimates between multiple hypothetical random samples. This is uncontrollable, one cannot do much about it. On the other hand, systematic error is also called as bias. It is a systematic error during the conduct of the study, during any phase, including study design, data collection, data analysis, or even publication. In an epidemiologic study, random error is measured through p-value or 95% confidence interval. To reduce errors from random chance, it is advisable to have a sufficiently large sample. Now, coming to bias, which is the focus of our topic and these sessions. Bias can be divided into internal validity and external validity, and this is the focus of the two sessions. Internal validity is the extent to which the results of a study, that is, the sample estimate, reflect the true situation in the study sample or the source population. Basically, a carefully designed and analyzed study would be internally valid. External validity is all about generalizability, that is, validity of the inference drawn in the study sample or source population as they pertain to the target population. Now let us get back to this figure that we had at the beginning of the session and try to understand internal and external validity. Where is it applicable in this figure? Internal validity is about how well the sample estimate reflects the true situation in your sample, while external validity is about how well the sample estimate is generalizable to target population. So, whenever we generalize our findings from a source population or study sample to target population, we should assess how representative our study sample or source population is of the target population. We ensure external validity by choosing a representative source population or study sample. In other words, a representative study population. We have come to the end of this session. In the next session, we will discuss in detail the threats to internal validity. Thank you.